Okay, good afternoon, students. So let us begin with the today's class. That is moving charges and magnetism. So idralli almost last part ಗೆ ಬಂದಿದ್ದೀವಿ ನಾವು. So Biot-Savart law, its applications, some of the numericals also we have discussed in the last class. So today we are discussing that is the expression for the force between the two straight parallel current carrying conductor. Okay, so we have the two parallel current carrying conductors. We are deriving the expression for the force in between them and define 1 ampere. This is 3 marks question. So ಯಾವ ರೀತಿಯಾಗಿ ಹೇಳ್ತಾರೆ, derive the expression for force between the two parallel current carrying conductors and define 1 ampere. So 2 marks for derivation, 1 mark for the definition. Yes, so let us derive this one. For that we are having the current carrying conductor as you can see there in the figure. So we have I1 and I2 are the two current carrying conductors. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ according to Oersted already ನಿಮ್ಗೆ ಏನ್ ಗೊತ್ತಿದೆ, whenever we have the current carrying conductors, so around that we have the magnetic field ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ, ಹೌದಾ? So charges move ಆಗುತ್ತೆ, charges move ಆಗೋದ್ರಿಂದ there will be a current flowing through them. So current iddaga there will be the presence of the magnetic field. So you can see andre illi one current in the andre for example I1 current eninde adrinda there will be a magnetic field in the neighboring conductor, and due to I2 there will be a magnetic field in the I1 conductor. Okay, so let us see how to derive the derivation. Okay, for that we have some of the considerations, like what we are considering, like xy is the current carrying conductors. Let you can name it as x and you can name this as y. So xy anta ನೀವು ಇದನ್ನ name ಮಾಡಬಹುದು. I1 and I2 be the current flowing through these two current conductors. Okay, then d or r is the distance between them. So in figure alli d r anta ide nane, okay, consider it as r, no problem. You can take it as r, you can take it as d also, that is r be the current flowing through them. Yes, now that is here what we are going to do is the next step, very simple derivation it is. So according to the current carrying conductor, the magnetic field is given by mu naught into I1. So I'm writing B1 is equal to B1 iddaga the current is I1 here, and this is 2 pi D. So ಇದೆಲ್ಲಿ ಬಂತು ಅಂತ ಅಂದ್ರೆ ನೀವು ಆಲ್ರೆಡಿ ಇದನ್ನ ಡಿರೈವ್ ಮಾಡಿದೀರಾ. After the Ampere's law we have derived this. See, after the Ampere's law we have derived this expression. Okay, Ampere's law define ಮಾಡಿ, based on the Ampere's law the current carrying conductor, the magnetic field is given by mu naught n into I divided by 2 pi r anta ide. So illi n number of turns illa, so therefore it is taken as 1, n is equal to 1. So expression enadagutte, mu naught I1 upon 2 pi r. So illi distance now small r tagondidivi, therefore we will consider it as small r. So what we are going to do here, students, that is the magnetic field B1 is equal to, it is mu naught I1 divided by 2 pi d. This is our equation 1. Okay. Instead of d, we have the small r. So let us make it as small r. Now, the next step, what we are going to do is the force expression we are writing, the force on a current carrying conductor y. So y conductor idanna now xy anta label madidvi in the beginning of the derivation. This is x, this is y. So the force on the conductor y is given by, the force on the conductor y is given by, so I'll write it as F1 is equal to that is F1 is equal to the magnetic field is B1 and the current in the wire B is what? I2. So I write it as I2 into L sin theta. Idi yav riti banta heli students, already ನೀವು ಏನು ಸ್ಟಡಿ ಮಾಡಿದೀರಾ, already you have studied the expression for the magnet force experienced by the conductor is given by Bill sin theta anta ನಾನು ನಿಮಗೆ ಹೇಳಿದೆ BIL sin theta. So if it is charge, we write this force as what? QVB sin theta. So as it is a conductor, we write it as what? BIL sin theta. Okay. So therefore we are writing it as what? Due to the conductor Y, the expression is F1 is equal to B1 I2 L sin theta. So you can name this as what? Equation 2. Yes. The next one, what we are going to do, the next expression is here, whatever the angle is there, the B1 is perpendicular to the plane of the paper. So as the B1 is perpendicular to the plane of the paper, the sin theta is equal to sin 90. And sin 90 will be 1 and sin 90 will be 1 ಆಗುತ್ತೆ. Okay, so when sin 90 becomes 1, the expression becomes F1 is equal to B1 I2 L. This is our equation 3. Okay, now what we are going to do, we are substituting the value equation 1 in equation 3. So you can see there equation 1, that is B1 is equal to, matte illen bandide, here we have F1 is equal to B1 I2 L. Now main expression derive ಮಾಡ್ತಾ ಇದೀವಿ, we are deriving the expression for the force between the two parallel current carrying conductors. So therefore equation 1 anna 3L substitute ಮಾಡಿ, that is F1 is equal to B1 I2 L. So what is B1? B1 is nothing but it is mu naught I1 divided by 2 pi R ಇದೆ. B1 I2 into L we are writing as it is. So if I do little arrangement of the equation something look like this. That is F1 is equal to, it is mu naught I1 I2 into L divided by 2 pi R. So this is the expression for force due to, here we have derived for the what? X conducting wire ig ಮಾಡಿದೀವಿ. So for Y conducting wire also same ಬರುತ್ತೆ. Y conducting wire igunu expression ಏನ್ ಬರುತ್ತೆ? Same ಬರುತ್ತೆ. So therefore in generally what we can write? In generally the expression for the force is written as what? That is mu naught I1 into I2 into L divided by 2 pi R. Divided by 2 pi R. Okay. So this is F is equal to the force between the two parallel wires current carrying conductors. Copy down the equation. If any doubt is there in any of the steps, you can ask. So I'll repeat. So first expression in bardidivi, that is the magnetic field due to the current I1. So magnetic field due to the current I1, what we have taken, it is B1 is equal to mu naught I1 upon 2 pi R. Next in ಮಾಡ್ತಾ ಇದೀವಿ, the force on the conductor Y we are writing. The force on the conductor, what Y in ಬರುತ್ತೆ, F1 is equal to B1 I2 L sin theta. Because ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು Y conductor ಅಲ್ಲಿ current ಏನಿದೆ I2 ಅಂತ denote ಮಾಡಿದೀವಿ. So but the magnetic field is perpendicular to the surface. For that it becomes 90 degree, therefore it is 1. So F1 is equal to B1 I2 into L, that is equation 3. Therefore the force is given by substituting equation 1 in 3, we will get it as F1 is equal to mu naught I1 I2 into L divided by 2 pi R. Yes. Copy down the steps. If any doubt is there, you can ask. Otherwise, copy it as it is. Diagram kuda draw ಮಾಡ್ಕೊಳ್ಳಿ. Yes, after completion in the chat box, you just message completed. so that I can tell you how to define 1 ampere. Just very simple derivation. So 2 marks ig baratte. And next you need to define 1 ampere. Okay. Yes. So see the final expression what we got, that I'll write here first. That is mu naught I1 into I2 into L divided by 2 pi R. Or you can write it as 2 pi D also, no problem for that. Okay. Suppose now here we are doing some consideration. So what consideration we are doing? Let us see. So the consideration is just rearrange this equation as F by L. Make it as F by L. And the numerator L anna ee kade tagolta idivi. So it is F by L and here it is mu naught into I1 into I2 divided by 2 pi R. Okay. Suppose if I substitute here students, see if I substitute I1 is equal to I2 is equal to, where if I substitute I1 is equal to I2 is equal to 1 ampere and the distance as what? 1 meter. The distance as 1 meter. Yes. So ಇಲ್ಲಿ ಏನಾಯ್ತು R is equal to 1 ಆಯ್ತು I1 I2 ಕೂಡ 1 ಆಗತ್ತೆ. ಹಾಗಾದ್ರೆ force per unit length ಏನಾಗಿದೆ? That is becoming mu naught upon 2 pi. ಹೌದಾ? It becomes mu naught upon 2 pi. So already mu naught value I told you, it is 4 pi into 10 raised to minus 7, but already divided by 2 pi ಇರೋದ್ರಿಂದ pi ಹೋಗುತ್ತೆ and 2 will get cancelled. So what we can write is, we can write it as what? 2 into 10 raised to minus 7. F by L irodrinda unit enagatte? Newton per meter. Okay. So based on this, how we are defining the 1 ampere? See here, the 1 ampere is defined as, it is the current which when flows through, so you can take down the definition, it is the current which when flows through infinitely long straight parallel wires, infinitely long straight, infinitely long straight parallel wires or conductors, you can write, which is separated by. So now R is equal to ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀವಿ? 1 meter ತಗೊಂಡಿದ್ದೀವಿ. Parallel conductors separated by 1 meter placed in free space, causes a force of, that is 2 into 10 raised to minus 7. That is 2 into 10 raised to minus 7 Newton per meter between them is called as what? 1 ampere. So usually ನೀವು ಇಷ್ಟು ಈ ಲೆಸನ್ ವರೆಗೆ 1 ampere ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡ್ತಿದ್ರಿ? You might have defined it like this. That is I is equal to Q by T ಬರೀತೀರಾ? I is equal to, it is written as Q by T. So Q, if I substitute 1 coulomb, time if I substitute 1 seconds, then it is defined as 1 ampere. So that is very basic definition. So here 1 ampere, how you are defining? Here how you are getting this 1 ampere? See, so when you are substituting R is equal to 1 meter, that time the force per unit length, how much it is becoming? 2 into 10 raised to minus 7 Newton per meter. Andre, ಎರಡು ಪ್ಯಾರಲಲ್ ಲಾಂಗ್ ವೈರ್ಸ್ ಇದ್ದಾಗ ಅದ್ ಎರಡ್ರ ಮಧ್ಯದಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ 1 ಮೀಟರ್ ಇದ್ದಾಗ ಅದ್ ಎರಡ್ರ ಮಧ್ಯ ಫೋರ್ಸ್ ಏನಿರುತ್ತೆ? ದ ಫೋರ್ಸ್ ಇಸ್ 2 into 10 raised to minus 7 Newton per meter. ಆ ಕೇಸಲ್ಲಿ the current will be defined as what? The current is defined as 1 ampere. So repeatedly read the statement, you will understand it. See what we are writing here. That is 1 ampere is nothing but what? It is the current which when flows through a long parallel, infinitely long parallel straight wires or the conductors separated by 1 meter distance placed in a air, it causes a force of 2 into 10 raised to minus 7 Newton per meter. So very simple definition. So wire ide, conductors ide, separation is 1 meter and the force caused by them is 2 into 10 raised to minus 7 Newton per meter, which gives the 1 ampere current. Yes, so this is 3 marks. Sometimes actually before deleting the syllabus, this question used to come for 5 mark. So ಈ lesson ಅಲ್ಲಿ ಒಂದು 3-4 derivations ಇದೆ. Those derivations they used to ask it in the 5 mark section. Okay, every year ಒಂದೊಂದು ಬರ್ತಾ ಇತ್ತು. So now we can expect it for either 3 mark, 5 marks it is doubt only. But if you prepare it is good. ಎರಡು ಸೇರಿ ಬರುತ್ತೆ ಆಯ್ತಾ. That is you need to derive the derivation and along with that define ಅಂತ compulsory ಬಂದೇ ಬರುತ್ತೆ. Define 1 ampere. Yes. So if they are asking to define 1 ampere anywhere, you need to write this definition from now onwards. Okay. So whatever that 1 coulomb per second is there, that is the school definition. So from here, the 1 ampere definition, we are defining it based on the force that is 2 into 10 raised to minus 7 Newton per meter. Yes, students, shall we go for the next point? So next again one derivation we are doing, that is show that a current carrying loop behaves as a magnetic dipole. Okay. Yes, the next derivation is, so we have little more in this chapter. Again tomorrow's class, again we have the derivations itself. Please keep yourself mute. Yes. So the derivation is show that a current carrying loop, a current carrying loop, a current carrying loop behaves as a magnet. It behaves as a magnetic dipole. Behaves as a magnetic dipole. Behaves as a magnetic dipole. So it behaves as a magnetic dipole that we are going to derive. Okay. So ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ನಿಮ್ಮ ಹತ್ರ current carrying loop ಇದೆ. You have the current carrying loop. This current carrying loop behaves as a magnetic dipole ಅಂತ ನೀವು ಇಲ್ಲಿ ತೋರಿಸಬೇಕು. ಯಾವ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ, ನೀವೇನ್ ಡೆರಿವೇಶನ್ಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ, ಈ ಡೆರಿವೇಶನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ, at the end if you are getting the term magnetic moment. So first 2 lessons ಅಲ್ಲಿ dipole moment ಅನ್ನ P ಇಂದ ಡಿನೋಟ್ ಮಾಡಿದ್ವಿ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್. So P is equal to, that is the distance into the any one of the charge, that is defined as the electric dipole moment. So here we have the magnetic dipole moment. So do the derivation, end of the derivation nimge m barta ide antandre m is magnetic dipole moment, which means that your current carrying loop is behaving as a what, that is magnetic dipole. Okay, so see how to do the derivation. So show that the current carrying loop behaves as a magnetic dipole. So for the derivation, first we are going to take the expression for the electric field due to the electric dipole along the axial line. So this you know already in the first chapter. Along the axial line, the electric dipole is given by, electric field intensity for the dipole is given by 1/4 pi epsilon naught 2pr divided by r square minus a square to the power of square. R square minus a square to the power of square. This is equation 1. Or else directly idr badlagi for the short dipole ane equation an bardbidi. We can reduce one step. So for the short dipole, it is 1/4 pi epsilon naught 2p divided by r cube. 1/4 pi epsilon naught 2p divided by r cube. Okay. The magnetic field due to the current loop along the axial line. So for this we have done. See, last class alli madidvi. The magnetic field expression for the circular loop is given by, if you remember, by using the Biot-Savart law, it is mu naught upon 4 pi into 2 pi I r square upon x square plus r square to the power of 3 by 2. This is our equation 2. Yes, so students, what we have done, the first equation is the electric field intensity due to a dipole, 1 upon 4 pi epsilon naught 2p by r cube. Equation 2 is mu naught upon 4 pi 2 pi I r square upon x square plus r square raised to 3 by 2. This is our equation 2. So I is current, r is the radius of the loop, x is the distance at where we are calculating the magnetic field. Okay. So otherwise the equation 2 for the short dipole, sorry, that is if suppose the distance, not short dipole, suppose a distance anna x is much greater than r, andre x value nimdu radius ginta ಜಾಸ್ತಿ ಇದೆ ಅಂತ ನೀವೇನಾದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, the equation 2 becomes b is equal to mu naught upon 4 pi 2 pi I r square. It is mu naught upon 4 pi 2 pi I r square upon, so r square anna denominator r square anna neglect madana. So neglect ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಉಳಿಯೋದೇನು x square to the power of 3 by 2. We are left with x square to the power of 3 divided by 2. So 2 cancel ಆಗುತ್ತೆ, ಉಳಿಯೋದು x cube ಮಾತ್ರ. Therefore the equation becomes, it is x cube. This is our equation 3. So I'll complete it. If you have any doubt, you can ask. Now in the equation 3, b is equal to mu naught upon 4 pi, mu naught upon 4 pi. So pi r square anta illond term ide, hauda? So here we have the term pi r square. You can see here pi is there, ill pi ide, matte illi r square ide. Yes. So here this pi r square is equal to, it is the area of the loop. It is the area of the loop. ಹೌದಾ? ಸೊ ನಾನು ಏನ್ ಮಾಡ್ಬೋದು, that term I can replace it as what? Area. So pi r square I am taking it as area. ಹಾಗಾದ್ರೆ ಉಳಿದಿರೋದೇನು 2 into I into a divided by, it is x cube. 2 into I into a divided by x cube. Okay. So now b is equal to the last step, mu naught upon 4 pi. Keep this 2 as it is. Keep this 2 as it is. The product of here, the product of current and the area, the product of current and the area is called as what? Magnetic dipole moment. It is called as magnetic dipole moment. Hagagi I into a enagatte m anta baratte. So it is 2m divided by x cube. So it is 2m divided by x cube. ಹೌದಾ? ಸೊ ನೀವು ಕೇಳಬಹುದು equation 1 ಯಾಕೆ ಬರ್ಕೊಂಡಿದ್ದೀವಿ ಅಂತ. ಸೊ equation 1 ನಾವು just comparison ಸಲುವಾಗಿ ಬರ್ದಿದ್ದೀವಿ. The electric field for the dipole derive ಮಾಡಿದಾಗ ನಮ್ಗೆ electric field intensity derivation ಅಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, 2p ಅಂತ ಬರುತ್ತೆ. So what it is showing, the p term is showing that it is behaving as a dipole ಅಂತ. ಹೌದಾ? ಸೊ ನೀವು ಇಲ್ಲಿ ಏನ್ ಡಿರೈವ್ ಮಾಡಿದ್ರಿ, ಇದರಲ್ಲಿ m term ಬಂದಿದೆ. m is the magnetic dipole moment. m is the magnetic dipole moment and it is given as the product of the current and the area. The product of current and area is called as the magnetic dipole moment. Yes students, is it clear? So first equation we have written only for the comparison. First equation bari comparison salvagi barkondidivi. Second equation en barita idara, that is the magnetic field due to a circular loop which we have derived by using the Bayes-Sarrett law. So same expression we are writing equation 2. Equation 2 dalli 2 steps follow ಮಾಡ್ತೀವಿ. ಒಂದು x value is much greater than r value ಅಂದಾಗ denominator r ನಾವು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬಹುದು. ಓಕೆ. ಸೊ ನೀವು ಅದನ್ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಉಳಿದಿರೋದೇನು x ಕ್ಯೂಬ್ ಮಾತ್ರ. ಅದು ಒಂದು ಪಾಯಿಂಟ್. ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್, ಇನ್ ನ್ಯೂಮರೇಟರ್ ನಮ್ಗೇನು ಪೈ ಆರ್ ಸ್ಕ್ವೇರ್ ಇದೆ, ಆ ಪೈ ಆರ್ ಸ್ಕ್ವೇರ್ ಅನ್ನ ಏರಿಯಾ ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ. ಎಸ್. ಸೊ ದಟ್ ಈಸ್ ಗಿವಿಂಗ್ ಯು equation 3. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್, ಇಲ್ಲೇನ್ ನಿಮಗೆ I into A ಬರುತ್ತೆ. ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಕರೆಂಟ್ ಅಂಡ್ ಏರಿಯಾ ಇಸ್ ಕಾಲ್ಡ್ as what? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಮೂವ್ಮೆಂಟ್. ಅದನ್ನ m ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾರೆ. ದ ಫೈನಲ್ ಡೆರಿವೇಶನ್ ಇಸ್ b is equal to mu naught upon 4 pi 2m upon x cube. mu naught upon 4 pi 2m upon x cube. So what it shows, ನಾನು ನಿಮ್ಗೆ ಮೊದಲೇ ಹೇಳಿದೆ ಡಿರೈವ್ ಮಾಡ್ಬೇಕಾದ್ರೆ, ಇನ್ ಲಾಸ್ಟ್ ಡೆರಿವೇಶನ್ ಅಲ್ಲಿ m ಬರ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಅರ್ಥ ಏನು? That is a circular current carrying loop is behaving like a magnetic dipole. It is behaving like a magnetic dipole aste. Idu bari equation comparison aste. Here we are not showing anything. We are comparing the equation and we are saying that, and we are proving that the current loop is behaving as a magnetic dipole. Yes, copy down the steps. If any doubt is there in any of the steps, you can ask. Okay. Yes, one more derivation, the last derivation for today's class. So today we discussed three derivations. One is the force between the two parallel current carrying conductors. The second one is a loop, how it behaves as a magnetic dipole ಅಂತ ತೋರಿಸಿದ್ವಿ. ಈಗ ಯಾವ derivation ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ, that is the expression we are deriving, the expression for magnetic dipole moment, expression for magnetic dipole moment, magnetic dipole moment of an electron revolving in of an electron revolving, once again, that is we are deriving the expression for magnetic dipole moment of an electron revolving in nth orbit, revolving in the nth orbit of an atom. Okay, so write the heading of the derivation. We are deriving the expression for the magnetic dipole movement of an electron revolving in the nth orbit. For that, consider a orbit of an electron. So central nucleus ಇದೆ. Here we are showing the electron. Okay, what all terms we are considering, that we will write now. So terms ಏನಂದ್ರೆ ಒಂದು v, speed of the electron. So v be the speed of the electron. So plus ZE anta ide, that is the charge of the nucleus. We are considering ZE has the charge of the nucleus. R is the radius. R is the radius of the orbit, radius of orbit of the electron, and ME is the mass of the electron, and E is the charge of the electron. ME is mass of the electron, E is the charge of the electron. Yes. So let us begin with the derivation. Okay. So what we are doing is, students, here as we know that the magnetic dipole moment. So already in the previous question we have discussed the magnetic dipole moment anna yav ರೀತಿಯಾಗಿ ಬರಿತೀವಿ ಅಂತ. The magnetic dipole moment is written as what? The product of current into area. So this is our equation 1. Okay. So now what I am writing is, we know that current is equal to charge by time. So current is equal to ಏನಂತ ಬರಿತೀವಿ? Charge upon time. But ನಾವು ಇಲ್ಲಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ ಸ್ಟೂಡೆಂಟ್ಸ್? ಎಲೆಕ್ಟ್ರಾನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ. ಸೊ ನಾ ಅದಕ್ಕೋಸ್ಕರ instead of charge I'll take the charge of the electron, that is itself E by T. But we know that I is equal to E divided by T. Okay. So this is my equation 2. Here whatever the orbit is there, it is a circular orbit. So circular orbit irodrinda the area will be what it is? Pi r square. So this is equation 3. Now substituting 2 and 3 in equation 1. Substituting 2 and 3 in equation 1. So when I am substituting through 2 and 3 in 1, what we are getting? C. That is nothing but M is equal to I value is E by T into area value is pi r square. Area value is pi r square. E by T into pi r square. Okay. Make this as equation 4. Just remember M is equal to what we have written? E pi r square by T. Make it as equation 4. So what is our aim? Our aim is what? We are deriving the expression for the magnetic dipole moment of the electron revolving in the nth orbit. So this is the magnetic movement correct ide, but electronic ide, but nth orbital ide anta navilli ತೋರಿಸಬೇಕಾಗುತ್ತೆ ಹೌದಾ? So for that reason ನಾವಿಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ನೋಡಿ next step ಅಲ್ಲಿ. Hope so till equation 4 is clear to everyone. Equation 1, by the definition, M is equal to I into A. And we know that current is equal to charge by time and area is equal to pi r square. We have substituted 2 and 3 in equation 1. So now speed is equal to distance upon time. Speed is equal to what? Distance upon time. So therefore, if I require time, the time value, the time period is given by what? Distance upon speed. It is given by distance upon speed. So this distance upon speed, circular orbit irodrinda, the distance is nothing but what? 2 pi r. ನಿಮ್ಗೆಲ್ಲರಿಗೂ ಗೊತ್ತೇ ಇದೆ. The distance of the circular orbit is given by 2 pi r divided by speed. You take it as v. So this is our equation 5. This is our equation 5. So substituting equation 5 in equation 4 now. Allalle substitutions, very simple derivation ide. Substituting 5 in 4. So if I substitute 5 in 4, enagatte? The magnetic moment is equal to E pi r square upon T ide. So T iddu 2 pi r divided by V. So divided by V anna nan reciprocal ತಗೊಳ್ತೀನಿ. So ಈಗ r cancel ಆಗತ್ತೆ, pi cancel ಆಗತ್ತೆ, ಉಳಿದಿರೋದು ERV upon 2. ERV upon 2. Okay. So for this equation, multiply and divide it by ME. So for the above equation, this is magnetic moment. Make it as equation 6. So for equation 6, multiply and divide by mass of the electron. Multiply and divide by mass of the electron. Yes. So to show it for the mass of the electron, see, that is m is equal to me. Me is the mass of the electron. E kade m irodu magnetic moment aita. Me ERV upon 2 into me upon 2 into me. Yes. So ಈಗ ಇಲ್ಲೇನ್ MVR ಕಾಣ್ತಾ ಇದೆ ನಿಮ್ಗೆ equation ಅಲ್ಲಿ. What you are observing, you are seeing here m, you are seeing here R, you are seeing here V. So what is MVR, students? MVR is nothing but what? It is the formula for angular momentum. See, ನಿಮಗೆ ನೆನಪಿದ್ರೆ ಇದು angular momentum ಅಂತ ಹೇಳ್ತೀವಿ. So MVR is equal to angular momentum. ಹಾಗಾದ್ರೆ ನಾ above equation ಅನ್ನ ಏನಂತ ಬರಿಬಹುದು ಈಗ? The above equation can be written as, ಅಲ್ಲಿ E ಉಳಿದಿದೆ upon 2me ಉಳಿದಿದೆ. ಉಳಿದಿರೋದೇನು E upon 2me. ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ? MVR is nothing but what? Angular momentum. So this is the magnetic momentum is equal to EL upon 2me. The last step according to Bohr's postulate. ನೀವು ಕೆಮಿಸ್ಟ್ರಿ ಅಲ್ಲಿ ಕಲ್ತಿರ್ಬೋದು, ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ atoms ಅಂತ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ಲೆಸನ್. ಸೊ ನಿಮ್ಗೆ ಗೊತ್ತಿರ್ಲಿ, according to Bohr's postulates, that is the angular momentum is given by nh upon 2 pi. It is nh upon 2 pi. So ನಾವೀಗ ಜಸ್ಟ್ ಇದನ್ನ L ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So therefore we are substituting this, if you want, name it. Equation 7, equation 8. So 8 and 7 will substitute ಮಾಡಿ. The magnetic moment is given by, it is N H E upon 2 into 2, 4 ಆಗುತ್ತೆ. So it is 4 pi me. It is 4 pi me. Yes. So see here students, what we are deriving? We are deriving the expression for magnetic movement for the electron revolving in the nth orbit. Okay. So ಅದಕ್ಕೋಸ್ಕರ first expression ಏನು ತಗೊಂಡ್ವಿ? That is the basic definition of the magnetic movement. That is I into A. So ಇದರಲ್ಲಿ I ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ A ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ವಿ. ಅದ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ಮೇಲೆ ಟೈಮ್ T ಬರುತ್ತೆ. ಸೊ T ಅನ್ನ ರಿಪ್ಲೇಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಪೀಡ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ತಗೊಳ್ತಾ ಇದೀವಿ, ಡಿಸ್ಟೆನ್ಸ್ ಅಪಾನ್ ಟೈಮ್. ಸೊ ಅಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಅಪಾನ್ ಸ್ಪೀಡ್ ಆಗತ್ತೆ. ಸೊ ಸ್ಪೀಡ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ 2 pi r by v. Then here substituting this time in the fourth equation. ಇಲ್ಲಿವರೆಗೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಲ್ಲ. ಓಕೆ, ಅದೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ equation 6 ಬರುತ್ತೆ. So equation 6 onwards, what you are doing? One step you are following, that is multiply and divided by me. So multiply divided by me ಮಾಡಿದಾಗ MVR angular momentum ಆಗುತ್ತೆ. So numerator angular momentum term ಬಂತು. According to Bohr's postulate, L is equal to NH upon 2 pi. Substitute ಮಾಡ್ಕೊಳ್ಳಿ. This is the derivation for the magnetic moment for the electron moving in the nth orbit. Yes. ಮತ್ತೆ ಯಾರಿಗಾದ್ರೂ ಯಾವ್ದಾದ್ರು ಸ್ಟೆಪ್ ಡೌಟ್ ಇದ್ರೆ ನೀವು ಕೇಳ್ಬೋದು. Copy down the derivation. If any doubt is there, please ask. Yes, okay. So please read ಮಾಡಿ. Okay, ಅವತ್ತಿಂದ ಅವತ್ತೇ ನೀವು read ಮಾಡ್ತಾ ಹೋದ್ರೆ, so whatever our program is there, it will be successful. Because already we have completed 3 topics. So physics ಅಲ್ಲಿ ಇದು almost 4th topic ಮುಗಿಲಿಕ್ಕೆ ಬಂದಿದೆ. ನೀವು ಈಗಿಂದ ಈಗ ಕವರ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ easily you can focus from July onwards. We can focus on the competitive part. ಹೌದಾ? So this 1 year you have to work hard, see students. ಈ March ಇಂದ next March ವರೆಗೆ. Then whatever your dream is there, you can achieve that. Whether you want to become doctor, engineer, or any degree you want to achieve, you can achieve that. So this 1 year work hard properly. ಏನಿಲ್ಲ, ಈಗ maybe you might have having holidays ಅಥವಾ half day colleges ಇರ್ಬೋದು. Just ಇದೇನ್ lessons cover ಆಗ್ತಾ ಇದೆ, ನೀವು parallelly ಓದ್ತಾ ಹೋಗಿ PCMB. ಸೊ ನೀವು ಇದು one lesson ಅಷ್ಟೇ ಸ್ವಲ್ಪ ಪಾರ್ಟ್ಸ್ ಕವರ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ, ನೀವು ಫಿಸಿಕ್ಸ್ ಶೆಡ್ಯೂಲ್ ನೋಡಿದ್ರೆ ಎವ್ರಿ ವೀಕ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್ 1 lesson. ಸೊ ಎವ್ರಿ ವೀಕ್ 1 lesson ಅಂತ ನಾವು ಕಂಪ್ಲೀಟ್ ಮಾಡಿ ಈ ಮಂತ್ ಅಲ್ಲಿ 1 month ಅಲ್ಲಿ 4 lessons ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. ಕರೆಕ್ಟ್? ಸೊ ಇಫ್ ಯು ಕವರ್ 4 lessons, At least if you are focusing only for the board exam also, 4 lesson ಅಲ್ಲಿ more than 40 marks ಸಿಗತ್ತೆ ನಿಮ್ಗೆ without leaving any options. Yes. So first 3 lessons allene 25 marks cover ಆಯ್ತು, and this one, so around 35 marks we have covered. See, okay, so copy down this one. Then next part, one more another 2-3 derivations are there that we can do in the next class, students. So meet you in the next class. Thank you. Copy down, then you leave.